Hello and welcome to India Career Center, the one-stop podcast for students, professionals, parents, and guardians. In every episode, we will try to deal with a current topic that needs expert advice related to career, career guidance, and career mentoring. Please welcome your host, Dr. S.B. Mishra, to the show. And happy listening.
Very warm welcome, ladies and gentlemen. We have today with us Reeshav from Canada. Reeshav is a specialist in the oil and gas energy industry. I've been quite fascinated by what's happening on the oil and gas industry because of the possible implication it has got on the climate change. And obviously the alternative energy is still not very developed as we speak, so we are going to see the use of conventional energy for some more time to come. So it would be very interesting to really learn a lot about what's happening on this oil and gas industry field and how they are getting ready for the future with one of the industry specialists, Reeshav here from Canada. Welcome, Reeshav, to the podcast, and I hope you're doing well. Good morning to you, first of all, because I think we're connecting with you. And as I am recording this today on 19th April, India time, it's about 9:15, and Reeshav is obviously into his work right now. He's taken a time out to talk to us from his office. Thank you so much to be with us, Reeshav, to talk to us.
Oh, thank you, Dr. Mishra. It is a great honor to be a part of your show, and I'm looking forward to this conversation. This is one of those topics which keeps me very fascinated as well. Even though I've been in this industry for 10 years, and with the fast changing environment, I feel like I'm still a student now. So it's always good to talk to somebody on the same lines, exchange ideas, and I'm glad that I got this opportunity to speak to you in this forum. So
fantastic. So Reeshav, as I normally do in my conversational podcast, I normally would like to know about my guest from their early life in India, because people who have taken the journey to move away from India and to do something in their respective field. So you could actually start about your life in India and how things have shaped you to take your decision about moving to Canada and to your profession. So I would want you to start with your early life in India.
Sure. So just for the audience, I grew up in India. I'm from Calcutta, West Bengal. As you can see from what my surname suggests, it's a giveaway. I grew up in Calcutta, finished my schooling with St. Augustine's Day School, and then moved to NIT Trichy, went through the same rigor of entrance examinations that you have to get into an engineering college, which most students still have to go through. Made my way into NIT Trichy as a mechanical engineer. So I would say that my intentions always were to stick to one of those core engineering fields, because that's what kind of fascinated me, or that's what I liked doing before I went to university. And then 4 years in NIT Trichy as doing my undergrad, BTech in mechanical engineering. And you go through engineering, it's a pretty vast curriculum, and I specifically found a lot of interest in fluid mechanics. That is something that has stuck with me for pretty much all of my career, doing fluid mechanics. While I was during my undergrad, I did a couple of internships in Germany, one with the German Aerospace Center and one with the University of Oldenburg. And both were CFD, computational fluid dynamics simulation type projects. And then when I finished my undergrad, I had a job with EIL, actually, Engineers India Limited. But I think my mindset was I wanted to do something a little more specific and do a bit of a deep dive, right? Because what I've found with engineering is like it lays the foundation, but it's more general for all. It doesn't let you pick what you really want to focus in on and do that little thing, which based on my research at that time, I knew a graduate program would allow me to do that. And so this is back in 2009, just out of a recession. And the US was in recession. And so I obviously, like many of you on this show and on the podcast, like coming from a middle-class family, sponsoring a full degree here in North America isn't cheap, and it wasn't something I could afford. So I did need like scholarship to pursue my master's, and I wasn't willing to really commit to a PhD at that time because although I knew what I was going to do with my master's, I wasn't sure the long-term commitment for a PhD was what I wanted. So this opportunity came up at University of Alberta here in Canada to do more fluid mechanics-based research, more on the nanotechnology side. And just to give you how that works out is like the province that I am in Canada is Alberta, and Alberta is a major oil hub. Like energy is big here. Like this is what it's kind of the economic powerhouse for the country, where it's like, you know, oil production, lots of there was a huge boom in oil production back in 2006 to 2014, I would say. And so, you know, fluid mechanics, oil hydraulics, you see where it's lining up. And so I'd done my research in porous media simulations during my master's, did a lot of coding and writing partial differential equation solutions kind of thing. And then finished my thesis, and then I got in an industry. Like I said, at that point of time, given my situation with my family and where my mind was at, I didn't want to continue my PhD. I just wanted to get into the industry and do more application-based work. And so I joined a company called Nova Chemicals as a research engineer, worked there for a year. And then since then, I've been a part of like TC Energy, used to be called TransCanada Pipelines back then. Spent six and a half years doing hydraulic simulations on pipelines. Like, you know, what should my pump operate at? What is my flow rate? Or you know, how much, at what pressure should I shut the pump down so that you don't overpressure the pipeline or risk a rupture on that, right? And so TC Energy is big in the oil transportation business, right? So we take oil all the way from north up here in Canada and send it down to Houston, Texas on the Gulf Coast of America. So it's a long line, long pipeline, 34-inch diameter pipe, which carries crude oil from a production center here in Alberta to a consumer market down in the US in the Gulf Coast where the refineries are. So that's what I've been doing. And then after I finished my hydraulics, I did some time with like measurement engineering and measurement technology. And right now I'm a part of the field operations team looking at the equipment reliability and doing more things like, can I plan for predictive failure analysis? And can I use machine learning to better know what my equipment is going to do so that you're cutting down on like redundant work or not wasting your resources or energy in that. So yeah, that's my background. So
yeah, so which means that TC Energy is basically into logistics. It's not really into exploration.
We are not a producer, yes. So we are not a producer. So oil and gas industry is basically divided into three segments, like the upstream, the midstream, and the downstream. Okay. So upstream guys are the producers, people who go into mining, go put the equipment underground, extract the oil, make it transportable, and then we take it as a gathering pipeline and then transport it down to the refineries, and they refine the crude oil into petroleum products, whether it's refined products, what you see in your gas stations is diesel and gasoline, or is it like other petroleum products that happen? We are a transportation business. We look at transporting the crude oil and gas from one point to another.
And this TC Energy company also supplies into Canada, or it is dedicated for supplying into US alone?
So the gas side of the business has supplies both all the way across the Canadian landscape. The liquid business is supplying primarily to the US refineries.
Mm-hmm.
So and again, if you looked at Canada, people visualize Canada as this cold place where, and it is right in a way, because the population of the US down south is a lot higher. So they're a big consumer of the oil. We are a producer, and we don't have the local market to consume all of that oil locally. So we have to send it abroad across the border to the US for consumption. And then, there are pipelines that are in the works that would take it to a port on the sea that can be loaded onto a ship and sent to Asia or Middle East or wherever there is consumption on that side.
Okay. So in terms of the oil requirement, Canada is self-reliant. I mean, Canada doesn't really import.
It's unfortunate. So we do actually import quite a bit of oil from abroad, from the Saudis and the Middle East. And it is a bit of a political cacophony, if you want to call it here, where we have the oil, but we don't consume it locally. We send it to the US, and there's lots of political drivers to it. One of the big drivers is what we're going to talk about is climate change and energy, right? So there is this feeling that we don't actually have a physical pipeline for liquids to be transported from the producing market, which is Alberta, to more the consumption market in Ontario, which is like the Torontos and the Quebecs, the Montreals, right? So we don't actually have a pipeline. We did propose a pipeline, but that got shut down a few years back because of, again, political issues, and that pipeline never got built. So we still import oil from abroad into the East Coast where it gets refined, and then we use it, and it's unfortunate, right? But the general notion at that time from the government was we can't. Some local jurisdictions weren't okay with having a pipeline running in their system because they said, well, if we allow you to build a pipeline, that's going to mean more oil production because you are now making more capacity available, and we don't want oil production to go up. So, I mean, right or wrong is another question. I personally don't agree with that because you'll still need energy going into the future. The demand isn't coming down, and you're still importing oil from outside. So it's not really you're stopping it. And if you look at it like the conscious effort made by the governments in the G7 is a lot higher to curb your emissions and make it clean and have proper policies around oil production compared to if you were to be in a place like the Middle East or China or Russia, where it's more a very dictatorship-based system. And I don't think there's any effort on that side to reduce oil production, right? Because they'll continue to capitalize. So it doesn't really make it fair, but it is what it is from a political perspective.
Okay, that's quite interesting. So, as you said, after completing your master's in Alberta, you started working and currently you're with TC Energy. So are you also parallelly planning to pursue the PhD, or are you pursuing PhD right now?
PhD? No, I'm not.
Okay.
I'm long. That boat has long sailed. No more PhD for me. I do want to keep learning though, and I think one good thing that has happened with the internet and all these, like the amount of information that you have right now, is you don't really need the excuse of a degree to learn. Mm-hmm. You can learn as you want to. Like, yeah, maybe not in the setting. And again, specifically with like family and work, I guess I don't have that amount of time to commit to a full-fledged PhD program.
Yeah, I understand. Okay, so now getting a little deeper into your expertise area, because I think there's so many interesting things which I also tried to, read through in the last few weeks after you shared some of those articles. And we'll try to pick up few of those points and try to understand those concept as much as possible. Um, so to start with, you explained about the three stages, which is the upstream, the transport companies, and the downstream. So all these organizations have their role in terms of reducing the carbon or decarbonizing. I mean, that's how you call it, right?
That's correct.
And there is a very interesting topic which came up is about the carbon capture. So would you like to explain the viewers and the listeners about carbon capture and how it works?
Okay, so basically, this is all stemming from things like the Paris Agreement, which the G7 had signed, and the idea is like, you want to go net emissions, zero emissions by 2050. And there is a huge investment going on pretty much around the world on things like carbon capture. And what carbon capture is basically, as you're burning fossil fuels, you're emitting all that CO2 into the atmosphere. The idea is to capture it before it's emitted to the atmosphere. Now, there's multiple ways to do it. One way is like post-combustion. So once the fuel is burnt, then you take the carbon from the flue gases. There's the pre-combustion one, which is like you convert the fuel that you're burning into carbon dioxide and a hydrogen mix, and then you extract the carbon dioxide part out. And then there's also like oxy-fuels, but essentially what you're trying to do is capture the carbon post or pre-combustion, then you pressurize and liquefy it into liquid carbon, and then you ship it across pipelines. And the use for that is you can either store it, or what they do is if you have a depleted oil reserve, you're pumping it back in there, or you are actually putting it in saline aquifers where there is, biosustainability kind of thing, right? So the idea is don't let the carbon go out of the atmosphere, capture it before, and then reuse it for, putting it back in the ground, so that you're not like increasing the CO2 content of the atmosphere. And the idea is, again, the long-term vision is you're trying to make sure that the average temperature rise for planet Earth is less than 2 degrees, is what the Paris Agreement is going for. That's the target, and there's huge investments everywhere. And I know that even TC Energy, we've started up like investments in carbon capture or hydrogen blending and like renewable energies and things like that. So,
okay, and this is something which is only there in the Western world, or it is a concept which is catching up everywhere across the globe?
I'm not super well versed with what's like India in specific. I know it is big in the Western world and in Europe. So the first CCU, the carbon capture unit, as you recall it, was actually built in 1996, I believe, in Norway. And I think currently operationally there's about 25 of them in operation. But those numbers are going up rapidly across the board. And I think, based on where you are, there's going to be more and more investments. I think it's a concept that everybody's going to ultimately catch up to, and we'll all get there. It's just like every country or every continent probably will be doing it at a different pace. Like I can tell you right now, Europe's far ahead of us in North America in that sense. So that is they're a lot more conscious in that side than here in North America. And part of it is also the population, the size of the countries. Like if you go to the Netherlands, there's a lot of like roads which are like bicycle only. Like you don't want to get into cars, right? Like walk, but you can't do it in North America because it's so large. You have to have a car to go from point A to point B. So there's those local domestic challenges, but I think it's something that everybody's going to jump on board soon.
So Rishabh, you are fairly young in your career right now in the oil and gas industry, and the way things are, we are in 2022, and maybe till about 2050 or 2060, we still are going to see the oil and gas energy being used. Though over a period of time, I think there'll be more reduction on the conventional use of the energy. For example, probably the passenger cars and small vehicles will rapidly move towards the the renewable energy, or maybe a hybrid energy. I don't know. I mean, I don't think we know the future as yet very clearly. But what about the big companies like, for example, Shell or British Petroleum, things like that, or how these companies are planning to be what they want to be, let's say by 2060, 2070? What would be their fate actually going forward?
Right. So as with any business, you have to be very, you've got to adjust based on market demands, right? So, and I can tell you, like, the upstream companies are spending a lot of money on, finding those efficiencies in terms of like, how can I reduce emissions? Like every big company here in Calgary, be it like the local Novices or the Shells and the BPs and the Exxon Mobils you've heard, like they've all committed to carbon neutrality by a certain time frame, be it 2030, 2050, and they're all spending money and spending time in research to develop these new technologies. Like you said, the energy demand of the world is still going up. We don't have the technology to offset all of it with renewables. Like, we talked about solar and wind. Those are two big ones that we have at a certain stage of maturity, but they're not nearly enough to meet the energy demand of the world, right? And a very good example of this is what's going on right now in world politics with the Russia-Ukraine war. And oil prices everywhere is shot through the roof because there's less supply and there's volatility, there's uncertainty, and then they're like, well, we need more oil. So supply is cut, demand's still high. So, and you'll see like little changes in political events impacting oil prices. So there's still the demand, and it is going to continue. It's not going to become zero, at least during my career is what I see it. But there's going to be more and more of these, fringe technologies coming up, but they won't be fringe anymore very soon. But these other new technologies coming up. I was actually reading an article yesterday where they said the cost of producing power through solar and wind has gone down by 56 or 70% respectively since 2010. That's a huge drop, when they started. So I think all these technologies, even carbon capture today is an expensive technology because after you capture the carbon, you need pumps and equipment to convert that into a liquid form. Then you transport it through a pipeline. So it works like a liquid pipeline, but it's not you still have to convert that process. So there is energy consumption there too, but you're doing an offset per se. And as we spend more time and money on this research, I feel it's going to make that technology more cheaper, more accessible, and more commonplace than what it is today.
Okay.
So, but like I said, in short, like all the bigger companies are actively pursuing that part, I think, and for their survival, this is necessary. Like they will need to move away from the conventional oil production. And frankly speaking, there isn't much growth happening on the oil and growth sector right now. The money is being invested in things like, we call it ESG, environmental social governance, which is your emission control, or renewable technology like carbon capture and storage, or hydrogen blending, and those kind of things, because that's going to be the fuel for the future.
So do you see these exploration companies? I don't know, I'm just asking a hypothetical question, because if solar energy has to become big, or the wind energy has to become big, obviously they have to be stored somewhere. And if for storing you need the batteries, and these batteries also need some kind of minerals. I think you need lithium, for example.
Lithium.
Or you need cobalt.
Lithium, palladium, cobalt, palladium, yeah.
So obviously these are material which are, I don't think they are also unlimited on this earth. So do you see these companies also getting into such mining activities as well going forward?
It's a good question. I don't know what they're going to do, because I know there are other companies that are more mining, like in South America, for instance, like lithium mining is big, and we'll get like lithium produced from those. And this is a common conversation too, and that when you're talking about, say, even electric vehicles, and saying it's much cheaper to charge up a electric car like a Tesla. There is a time when you have to dispose of the battery. If you don't have good governance process to that, you're going to end up in the same boat as you're today, maybe in 100 years time. So that is a risk. And you're right, like these things have to come from the ground as well. These minerals that you need for making batteries have to come from the ground as well. I haven't heard much, to be honest with you, around these companies going directly into mining. There are other companies that do the mining and do the battery production, but everyone else is looking at storage for sure. Like power storage is a thing for sure, like battery banks and power storage. Yes.
Okay. Now we talked about the conventional energy, probably reduction of it or becoming hybrid as we go along in every year or every decade as we go along for the smaller vehicles and things like that. But big transport equipment, for example, aeroplanes or even ships or maybe trains, I don't know, everywhere trains cannot be electrified actually. So for them, what is the way forward? How things are shaping up in that area?
So that's an interesting question. So I don't know if you followed, but there was in March this year, Airbus actually did a pilot with what they call the SAF, or Sustainable Aviation Fuel, which is a mix of cooking oil and waste fats. And the idea is they flew for 3 hours on an Airbus A380, which is the biggest commercial plane out there, flying from their French headquarters in Toulouse to somewhere down south. It was like a 3-hour flight, and they repeated that again in between Nice and Toulouse, I think. So they did 2 of those, and they're moving towards it. So that's just sustainable fuel, one part of it. There is this research wing that they're looking at, moving into the more sustainable fuels to offset your fossil fuel consumption in that sense. And every company is doing it. That's one aspect of it. The other aspect of it is, well, how do you reduce your emissions and reduce your fuel consumption? So if you look at the new age airplanes today, like the Boeing 787 Dreamliners, or the Airbus A350, even the 737 MAX, which has been spotlight to a lot of controversy. The idea is they have bigger engines, and you're saying you're cutting your fuel consumption by as much as like 2 to 5% at the very least. Even minor changes like that is huge for the airline in terms of reducing operating cost and reducing emissions, because you're using less energy, right? So that's where the research, it's like a parallel front, like how do we reduce emissions? And then also how do we use like not your standard aviation fuel for the industry? So I think they are also heading into that direction. And this is the other part of your question. I mean, if you look at who supplies all these fuels today to the airlines, it's the Shells and the BPs. So clearly they're not going to be sitting around to give away their market capture. So that's how they're going to start spending money on research to develop all these alternate fuels so that they could supply the aviation industry with that renewable energy.
Okay. And on the similar line, I think even hydrogen as a alternative fuel is something which is coming up. I would say it still at an experimental level. I don't think it is in a large scale commercial stage as yet. But in some part of Europe, I think it has started some amount of commercial operation as well. I think London has some hydrogen powered buses now actually. So that's one area which is also parallelly developing. But as an expert from the industry, what do you see about this development on hydrogen as an alternative fuel?
Right. So I think in North America, it's just getting kicked off as the new fuel, the clean fuel, if you want to call it. There's pockets of it here and there, of course, but it's not to the point where it's commercially, you see it everywhere. And like I said, it's something that is just being kicked off right now here to say, well, let's spend some money in research on things like hydrogen blending and, hydrogen fuel, hydrogen as a fuel to vehicles and green energy. It's not, I would say, as matured yet and again, you'll see all of this mostly coming out of Europe because they're ahead of North America in that sense, I think. But it's something that we're all catching up to. It is also, those two are the big two, like carbon capture and hydrogen. Like those two are the two big things that are right now in the spotlight for, replacing or offsetting some of the fossil fuels, minus the battery and the electric vehicles, of course. Like if I look at the road right now with the cars that are going on, every manufacturer is coming up with the electric version of the vehicle off the vehicle or some sort of a hybrid. And to be honest, like I've driven one myself, like the amount of energy efficiency you gain out of it is phenomenal, right? Like on a hybrid vehicle, your mileage is significantly higher than what it is on a purely conventional gas powered vehicle, right? So I think coming back to the hydrogen point, it's coming along. It's still not as loud as the other energy sources. Like electric vehicles are the big ones, of course. Carbon capture is the other one. Hydrogen still is like, it's in development phase, like you said. It's more experimental. Okay. And part of that I feel is again because we don't have the infrastructure to do that kind of thing yet at a large scale. So that's where the research and development is going to happen. And I think 20 years down the line, you might have instead of oil refineries, you might have like hydrogen processing facilities, right? So
very, very dynamic industry you're in actually. I mean, that's going to be every day something new coming up.
Yes, so that was my comment right up, right? Like when you graduate from university with a certain amount of skill set, then you have to continuously keep up with the current times to make sure that you're still relevant in the industry, because what you did for oil, it'll slow your growth down if that's what you want to do. And it is exciting. That to me, there's nothing more exciting than trying to figure something out right from ground zero and scratch and then building it up to a point of maturity. It's good to be a part of that change.
So as you mentioned earlier, you are now handling a team which looks at the preventive side of the business in terms of you're trying to basically address efficiency and look at where are the problems, bottlenecks, trying to remove them. So would you like to explain a little more about this, how you go about doing it and what technology support you're taking?
So again, coming back to my team, we're just mostly reliability focused, equipment reliability. And the idea is, of course, you want to prevent things like repeat failures. Like one of the things we do in reliability is called bad actors, if you want to call it, which is like you look at a pump or a motor and see, well, is this failing every 4 months? Although we do maintenance on this, sorry, my light keeps going off, but you do maintenance on it every year. But then why does it keep failing every 3 to 4 months? Like what's going on? Do we need a design change? Or do we need to reassess our maintenance philosophy? And and that's the efficiency you're trying to do, because here's one thing: when an equipment shuts down and you're trying to bring it back up again, it's a pretty high consumption of energy to start the system back up again. Also, as I told you, it's a long pipeline. So we've got pump stations in remote places, right? And sometimes, if you have to actually go to site to fix a problem. This is at 2 a.m. in the morning. A technician gets called saying, hey, something has broken in this pump station. Can you drive up? It's an hour's drive one way just to get to site to fix this problem, come back. So if you have more of these, you see you're spending resources, you're putting more vehicles on the road. There's a safety issue out there as well. So you can have efficiencies there, or you don't need to spend too much time, if you're doing maintenance every 1 year and you see that, my equipment isn't really failing within 1 year. Do I need to do that maintenance in 1 year? Can I now stretch that maintenance out to 2 years? One good example is a car, right? Like, so when you buy a car, the manufacturer will tell you, go change your engine oil every, 20,000 kilometers. But do you really need to go change your car after 20,000 kilometers? Because I know for certain, like you could exceed that amount based on actual data monitoring from the system. So coming to the technology part, what we've done is like we've put a lot of focus on the quality of data that we're getting from the equipment back for analysis. And then you can look at trending, you can do forecasting, you can do things like Weibull analysis to say, when should I replace this equipment? Is it happening because it's a random failure, or is this age related? Should I replace it before it fails? Have that contingency plan. Do more of those predictive based type maintenance, or look at data, and data analytics is big right now. It's like look at that data and see where are your bad actors, how many hours have you spent, how much throughput have you lost, and then you throw in some machine learning on it and say, can you now predict based on the historical failures? Can you now predict when the next one's going to fail so that you get planned for it, right? And then you can repair it. So that's one part. The other part that I'm also doing is I recently have started collaborating with my grad school supervisor, and he's the CEO of this company called Intelliflux Controls. And what they look at is closed loop process automation, which is you have a process plant, like say a water treatment plant, and you got a filtration system which is getting dirty because you're trying to filter out dirty water for clean water. And typically with all these, these heritage plants, what they would do is they've got these set routines, like from historical experiences, like, every 5 days I might go have to change a filter. But then you don't actually need to, because you can now have the data coming back live from the system, monitor it, and give you a feedback saying that, now is a good time, because now you're seeing that your filter is getting dirty, your differential pressure across the filter is changing. So you do it more on an educated basis rather than just like, I'm just going to go change a filter because that's how I've done. So you have efficiency, you're not wasting the total capacity of the filter, because it could probably still run for another 5 days and be okay. Whereas if you were to do it, just do it based on that. You may be too early or you may be too late where it's gone into the failure, right? So that's where technology comes in now, is like there's so much focus on gathering data and dissecting and playing with the data to analyze it and drive to decisions based on condition-based equipment maintenance is huge right now. That is a big direction that every company is going.
So which means that all this data is actually collected through a lot of IoT sensors and things like that?
It is, that's correct. So a lot of these IoT sensors come in from like smart transmitters, smart sensors, and vibration monitors and things like that, which go into a central, like that, all that data comes in and goes into, like, I'd say something like a database or a historian, where it's now pulled in, and you take the data and you do your computation in the cloud, and you send recommendations based on your computation to the controller and say, here is a red flag, here is an alarm, you should go now trigger maintenance to go clean out that filter, kind of thing. And even the end goal is to do a closed loop automation where you don't even actually have to send a recommendation to the controller. You put in safeguards, but you let the cloud push in commands to the equipment saying either shut down or slow down or do a backwash or whatever you want to achieve, but it's all automated. It's like literally running your plane on autopilot.
Okay. Now moving on, another interesting concept I came across is about the twins, the digital twins.
Right.
So what exactly it means in your specific industry and why it is so important, and what is the concept, first of all, to explain to our listeners?
Which means you have so I'll say this, like, let's say a separator or a pump maybe, right? So you have a pump, you are modeling the actual pump as it is happening on the system. So now you can, instead of actually looking at the pipeline or going out to site, you can look at the digital twin of the system, which is connected to the sensors at the pump, and it's giving you an output model. And it could show you when you did your last maintenance or how much time you have remaining for your maintenance. And this is extremely important, or this is what helps us better operate the facility in a more efficient way. Things like reducing emissions, like a digital twin, what it will do, for instance, like I'll take the filtration example again, is now you have a filter system where you are continuously monitoring the permeability of that filter from the sensors, from the pressure and flow across the filter, and feeding it to a digital twin. The digital twin basically models the physics of it and says, this should be your output. And you're monitoring that output against the output of the actual process. And as soon as you start seeing those two things deviate, now you've got a flag for something we call an anomaly detection, right? And that's what the digital twin allows you to do, is to look at the system and not just, typically with plants in the previous generation, you'd have to go to site, look at the alarms at site, look at the readings on the transmitters. Whereas a digital twin is you're taking all of that in and making a model on the side, and then saying, okay, as I get the live input feed from the process, I'm going to model the output feed if my equipment was in good condition. Now, as that deviates, you know that there's a flag, there's an anomaly. Now you go trigger your maintenance. That's what a digital twin does. And you could do a digital twin for everything pretty much, like, filters, pumps, valves, based on, we have, like when I did transient hydraulics, that's an example of a digital twin where you have it's not with live data, it's model data, but it is like you have the entire pipeline with the pump stations, the PID control loops modeled in, and then you say, okay, if my pipe was flowing at 4,000 meter cubes an hour, and then I suddenly close a valve and create that water hammer, what is going to be the impact on the pipe? So this is what allows you to plan and advance and put in safeguards for safety, better efficiency, less number of failures. That's what a digital twin does.
Also, listening from you on the digital twin, one is, of course, you can look at what's happening on the live side of the data and how it is modeling as an output. Is it also important role while designing a system itself?
Yeah. So I guess part of the design also comes in, like, if you want to have a digital twin, you design your equipment with the right amount of sensors and the setup for the process so that you can model it, right? Like for me, for instance, if I want to build a digital twin, I need to have the right amount of data going into it. And that data has to be, it's the data structure and flow, right? Like it has to come from the field, the actual equipment, go to a central historian through a supervisory control type architecture. And then that feeds into your local model, right? If you don't have that data flow architecture, then you can't build your digital twin, right? So the equipment has to, so every equipment pretty much in a process plant works on something called a PLC, which is programmable logic control, which is a local computer which tells you when to start, when to shut down, what are the set points for maximum operation. But that data has to be, it cannot just stay local to site. You can't really build a digital twin then, right? Like you have to have that data architecture to bring all the data back into a central cloud server, where you can now use it to build your digital twin and make decisions. And also, if you want to do closed loop automation, to feed that information from the digital twin back into the equipment through that same data highway, if you want to call it. Right? So yes, there is a design. You've got to set yourself up to be successful to use a digital twin. You've got to build those architectures in.
That's quite interesting. So now going forward, we talked about, I think, the concept of carbon capture, digital twins, and also very much we covered about how the energy companies are planning for different types of research and development. So any young person from India, planning to get into this particular industry, either in India or in Europe or Canada or anywhere in North America, what would be your advice?
Right. So, I will say, like, this is one of the challenges that we see is it's a challenge on one end, and it's also like positive on one side. So, the conventional education that we get in India, graduate or undergraduate, I think is still, the curriculum was designed back in the day. It isn't as relevant as anymore, kind of thing. That said, though, I will say one thing that has happened with all this data revolution and carbon capture and all of this is people tend to look at from a very surface level, which is like, oh, I'll just take the data and make decisions. There's a big gap in the actual physics side of it, and that is one of the recommendations I always say to people coming out of the universities. Don't look at your university degree as oh, this is my specialization. Focus on the tools and the skills you learn. Because tell you what, I can do carbon capture, but at the end of the day, it's still a liquid product, which I'm transporting in a pipeline. You'll have the same sort of fluid equations that you used for anything else. Yeah, your operating limits might change a bit. Your physical properties will change a bit, but it's a liquid that you're transporting at the end of the day without knowing. So the physics doesn't change. Or, if you're doing filtration, you're using the same mass transport, energy transport equation that you did back in high school, not high school, but like your undergrad university. So I think it is important to understand that, and this is, I'm more talking from the mechanical, electrical, the civil side of things. Like, if you're a computer science program, I think their curriculum is still a little more updated to what you would see in today's world. But you've got to understand, like, technology is developing at such a fast pace that it's not possible to keep changing your curriculum every day based on that, right? So you'll have to stick to the core values. So my recommendation always to young people coming out of India is get your basics solid. And then as you get into the industry, you've got to be a continuously learning person where you need to do, like back in the day, when I graduated, there was machine learning was almost not there, right? Like it's been a boom over the last few years. But if you look into machine learning, they talk about machine learning, but what is machine learning? It's about taking historical data, and it's nothing but a regression analysis. It's curve fitting, and then building confidence in your curve to say, well, I only have data up to this point, but my line is going in this direction. This is where I think things are going to fail, right? That is machine learning. So again, are you using any concept more than statistics? You're using the same concepts of statistics to build new algorithms to solve your problem. But if you're good at statistics and you're good at algorithms, it'll be easier for you to pick up the new skill. And that is the biggest thing, is you have to be continuously able to learn and keep up with it and make those incremental steps based on your basic education in undergrad, and use it as an application. Because if I just sat around doing CFD, I'd be out of business in 5 years, like literally. I have to keep myself more updated and be aware of the new technologies. And it is exciting. Like, it's like, how can I use my existing skills to impact or make an impact on the industry of the future? So yeah, my suggestion is start with your basics. As you get into the industry, I'd say keep yourself learning. And there's like tons of courses out there which are like boot camp type courses, or there's a site called udemy.com, which is basically you can pick anything under the sun, from photography to crypto mining to machine learning to Python. It's out there and it's cheap. It's like you spend 50, 60 hours learning online at your own pace, and you pay nothing but like, well, in Canadian dollars, like 20 odd dollars, which is like, if you take it in India, it's like 1,200 bucks, which isn't very expensive, but that gives you that launch pad to say, okay, now I know I've added these skill set to my existing skill set. Now I'm I'm more relevant to different industry applications today. So that would be one. And one, I always say, like, it's always good to know one programming language, given how things have gone in the direction of data. Any kind of object-oriented programming, Python is the one I personally recommend, because I see the usage of it everywhere. But just to have the ability to be able to have a programming language in that sense, if you want to be in the technical field and industry.
Okay, so very clearly what you mentioned is that keep learning, keep yourself open and updated, because the world of work will continue to change rapidly.
Absolutely.
So not just the technical knowledge, I guess you need to also pick up the other soft skills to remain
Absolutely
relevant, I think, in the industry, and keep adapting, because I personally see that maybe in about 8 to 10 years time, probably the concept of job will go away actually. And
absolutely,
it'll get replaced by contracts and specialized contracts. So
yeah,
maybe if today companies are having 100 people, they will have 20 people, and balance 80 jobs will be actually contracted or given as a contract. That's how I see it. I don't know what you see from the industry point of view.
Well, yeah, that is a possibility. I'll give you another perspective with all the COVID thing happening, right? Like, your home is now your new office. It's remote. Like, I'll tell you, like, companies like Amazon it's heavily remote right now. Like, you don't need to be in one city to be able to do that work. So you're right that your skill set and your ability to adapt in those conditions is going to be paramount. And this is not the last change you're going to see. It could very well be that people become more contract based, and just to keep them floating and nimble, you can go from one place to another and things like that. So and I would also say, like, for people coming out of India from grad school looking at coming abroad, a big part of it is the social integration. And how do you, because you are at the end of the day coming to another country, you'll have to learn their ways. You can't say I'm from India and this is how I work. Like, obviously you'll hold on to your roots, but there's a certain amount of adjustments that is required in the local market. As like they say, when in Rome, you behave like a Roman, right? So that is required. The way people work, the way people talk here, right? Like, I can tell you, like, even across the border in the US and Canada, the conversations are very different. Like, the way we used to have conversations in India, we can't have those conversations here because those would not fly very well with people, right? So and so that is absolutely right. It's always important to embrace change, and and in a good way. Like, know what is good and bad, make that analysis, embrace the change for your own betterment and development.
And how has been your personal journey since the time you landed in Canada?
I've had a really good journey. My story is no different, I would say, from any other immigrant student. Like, when I came in, was on scholarship. It was like bare minimum money. Like, I was lucky because I had like three students. The three of us came in from the same university, which was NIT Trichy. So I had that backing. Slept on the carpet. Literally came here with one suitcase, one laptop bag, and $600 in my pocket. That's all I had. Slept on the carpet for the first couple of weeks here. Once I found a rented place. and then you grow. But I can tell you, this place has been really good. There's a lot of opportunity to grow and develop. Also, it's less populated, so competition-wise, there's more opportunity, supply demand in that sense, right? Like you've got more opportunities, less people, so there's easier to fit those in. And one thing I always say is, coming from India, if you've made it this far, you've got to have the confidence that you're good in some way or the other, and people recognize it here because you've gone through the competition, you've made it here. You should be able to carry that through with your career as well, and then you grow. One big thing that people often ask me is about racism, and do you have discrimination? I've not felt it for once. I've got really close friends from work who are Caucasians here, who are local Canadians, right? And it's not looked upon like that at all. So I've had a really good time. I've grown within this company and career, and like I've said, I've gone from we call it engineering and training, which is like a probationary apprenticeship type engineering role, to now being a manager when I'm leading a team of like 14, 15 people across US and Canada. And this is a Canadian company. So as you can see, I've not felt discriminated. I've had a very good run. People are very friendly here, and mostly, they're, one joke we say about Canadians is like they say sorry and thank you way too often, more than what is required. But no, I've had a really good run. I've enjoyed my time here in Canada, and it's become my home right now. So I've been here in Alberta since I've come to Canada. So, but no, I'm very thankful and very happy with what I have today.
Fantastic. I think, Reeshav, it was very nice to really know a lot about what's happening in the oil and gas industry and your personal journey in Canada. Thank you so much for sharing all the insight. And I know as you mentioned, the landscape of this industry will keep changing, and we will continue to collaborate and probably catch you again at some point of time to see what's new happening again. Because as the climate change is such an important topic today, I think it will continue to be at least till 2050, 2060, if not beyond that as well. Because I think by that time, hopefully most of the countries across the world will have a committed way of going forward and really restricting the increase of temperature, capped down to a level of below 2 degrees. And I guess the aim is to keep it at 1.5 degrees. So I really don't know how things are going to pan. But I think big countries like India and China are making those commitments. How much of it is going to happen on the ground is something we have to see. But at least there's a political talk which is going on, which is so important as well. So
yeah, and I just on that note, I think India is committed to like zero emissions by 2070 is what I've heard. And you have to be fair to people as well. The socio-political fabric in India is not conducive to do the kind of things we have here. And I always say that example, right? For a middle-class person here in North America to buy a hybrid vehicle is a cheap thing.
Yeah.
If you're talking about doing that with an auto rickshaw driver in India, it's unfair to the guy. He's barely earning enough to make ends meet. So you've got to keep, and the population is also so large, right? So there's got to be that balance. You've got to keep it practical. I think India is going to be a big force because, one thing I've seen is, for us Indians, the ability to think and improvise and innovate is really high. That just comes from the fact that there's so much competition. And if you look at the workforce today here in Canada and US, is a lot of it is like Indian and Chinese people working in the industry, right? So I think there'll be a workforce and total powerhouse in the changing energy landscape as well. So, but it might just happen that they might be selling the services to another country initially before they can actually implement it in India.
So you see a good amount of opportunity in the oil and gas industry also for people to come in as students or as immigrants into Canada?
So I would say for a new student coming in, I would say the focus should be on energy, not just oil and gas, because as a new student, the way I looked at it is I felt what keeps me interesting is what do I do next? I don't like doing the same old mechanical stuff every day. It's like, what can I improve? What can I change to make the system better? And those opportunities with passing time, I would say, would start going down because we're not building any more new pipelines here in North America per se, right? So a lot of the growth will be happening in the environmental, social governance, ESG, green technology focus. So I would say, like I said, keep the mind open, and energy as a whole is going to go up. Whether that's oil and gas, or that's LNG, or whether that's hydrogen or carbon capture, all of that is going to go up because the world's population is growing and the energy demands are growing as well. Absolutely. So as long as you know how to, like I said, use your university skills to solve a practical problem, you'll still be relevant. But it shouldn't be like, oh, I want to go into just that industry kind of thing, right? So Fantastic. It's best to keep your mind open and say, I want to focus on the energy industry per se.
I think that's a very fair point. You're right. Today we are, I think, about 7.5 billion people on this earth, and the estimate is that it will become 11 billion by end of this century. So if that's true, obviously you need a lot of energy, a lot of food, a lot of healthcare. Yeah. I think these are the industries which will continue to be evergreen, and I think young listeners or viewers who are watching us, I think, should pick up this. And Reeshav, before we end, I would like to ask you, you talked about updating yourself continuously. So do you have any recommendation for books for young people, or any other method of continuously learning?
Right. So I'm one of those kinds that needs to do thing to learn. I'm more hands-on, right? So obviously keeping yourself with like articles on energy change is a good thing. Like find a magazine, or anybody who in India right now has a Google podcast or a Spotify account, or you'll find lots of podcasts talking about energy development and the latest technology that's coming. That's just to keep yourself up to date. And then I think the internet is your biggest resource. Like there's so much out there that you can learn from about carbon capture and hydrogen blending. And then if you want to pick up specific skills, like I said, like you want to pick up a programming language, or you want to learn about machine learning or AI, and how that can be used in things like making greener buildings or things like that, go find a bootcamp course. Like go to Udemy and look up an AI course and do it at your own time. Like, you don't need to have the exclusive degree. And the best part is if you go to LinkedIn, it's these boot camps are actually recognized as proper courses, and they do provide certificates for that. So you can actually tell your employer that, I've done this. I know, here's the proof of it. And I can give you examples of what I've done. And so, I would say like those boot camps, podcasts, reading up online is the biggest thing, because like a lot of these books, even when you're talking about it, by the time the book comes out, the world's moved on, right? So, would you want to and talking about ESG, get away from paper anyway. So, but no, I mean, it's all very dynamic and very fast. So it's best to, I'd say, resort to things like magazines and find out what's going on around the world.
Fantastic, Reeshav. Thank you so much for talking to us today, and
it's been a pleasure.
surely we'll catch you again once as we go along and see what's happening new in the industry, and maybe next time we talk about energy rather than just the oil and gas.
Absolutely. And I'm sure there's going to be more at that time than it is today.
That's right. Thank you so much.
Thank you, Dr. Mishra. It was a pleasure talking to you.
Hope you enjoyed this episode. We sincerely wish you could take something from our conversation today and be able to apply it to your life in a positive way. We value your feedback. This can help us improve our future episodes. So share your thoughts to serve you better. If you want us to focus on a topic which you think is of importance, let us know. We will share our expertise in future episodes. So, see you soon with a new topic and help you in your career journey.